Today we are going to start science chapter number 2, sorting materials into group. This is of class 6 NCERT. So I completed chapter number 1 in class 6 NCERT in the previous video I have uploaded. So today I will start this new chapter, chapter number 2, sorting materials into group. This is part 1 of chapter number 2. So this is 2.1, objects around us. Yes. We have seen that our food and clothes have so much variety in them, not just food and clothes. There are such a vast variety of objects where everywhere we see around us a chair, a bullock cart, a cycle, cooking utensils, books, clothes, toys, water stones, many other objects. So mainly in this paragraph, the author is trying to say that there around us there are many items that are made by us. So like a chair, bullock cart, cooking utensils, books, clothes, etc. All these objects have different shapes, colors, and uses. So here you can see that this is a toy, a lock, key lock, a CD, yes, a telephone, yes. So look around and identify objects that are round in shape. Our list may include a rubber ball, a football, and a glass marble. If we include objects that are nearly round, our list could also include objects like apple, oranges, and a tin pitcher or garha. So, in this paragraph, author is trying to say that you have to make a list to identify which shapes are round, which are square, which are cube, which is cuboid. A list may contain your list should be contain rubber balls, footballs, glass marbles, dices. Yes, if we include that are round, our list could also include like apple, oranges, and earthen pitcher. Yes. Let us say we wish to make a group of objects that are made of plastic buckets, lunch boxes, toys, water containers, pipes, and many such objects may find a place in this group. There are so many ways to group objects. In the above example, we gave grouped objects on the basis of the shape or the materials they are made from. So in this paragraph, the writer written this book says that you wish that to make a group of objects that are made from plastics, buckets, lunch boxes, toys, water pipes, etc. And you may find in this group that there are so many group of objects in the above example. We have grouped objects on the basis of their shape or the materials they are made from. For example, toys. All the toys are made from plastics. Lunch boxes, some are made from steel, some are made from stainless steel, some are made from iron. Yes, water is made from H2O, hydrogen plus 2 atoms of hydrogen plus 1 atom of oxygen, and then we make a molecule. And pipes, and there are many pipes like PVC pipes made from hard plastic plus steel pipes. Yes, many such objects. All objects around us are made of one or more materials. These materials may be glass, metal, plastics, wood, cotton paper, mud, or soil. Yes. Can you think of more examples of materials? Yes, you can think so. Yes. Activity 1. So activity 1 says, let us collect as many objects as possible from around us. Each of us could get some everyday objects from home And we could also collect some objects from the classroom or from the outside the school. What we will have in our collection: chalk, pencils, notebook, rubber, duster, a hammer, nail, sword, spoke of a wheel, bat, matchbox, sword, potato. We can also list objects that can be think of but cannot bring to class. For example, wall, trees, doors. Yes, because walls, they are trees, doors, tractor, roads, they are all fixed. If once they are made and then fixed, it can't be replaced. Yes, so this activity you have to do. It's very interesting. Yes, separate all the objects from this collection that are made from paper or wood. This way we have divided all objects. Just a minute, let me change my page. So here we are into two groups. One group has the objects that are made from paper or wood, while the other group has the objects that are not made of these materials. Similarly, we could separate the things that are used for preparing food. So this is activity 1. So you have one group that has the objects that are made from paper or wood. So what are the objects that are made from paper or wood? Paper, the objects made from paper are origami that you make by hands. Wood, from wood, paper is made furnitures. Yes, furniture like chair, table. Um, from paper we can make cardboards. We can recycle and then make cardboards. Yes, from paper. Okay. Yes. Let us be a little more systematic. List all objects collected in a table. 1.1. Try to identify the materials that that each one is made of. It would be fun to make this a large table information collecting information about many objects as possible. It may seem difficult to find out the materials out of which some of these made objects are made. In such cases, discuss with your friends, teachers and parents to identify the materials. So like plate or thali, steel, glass, plastics, and then pen, plastic, metal. So let's take chair. Some chairs are made from, let's say, some chairs are made from iron, wood, plastics. I'm filling in this box, okay? And with chair, you can take table. From table, there are steel tables, wood or plastic tables, or glass or a glass. Yes, so these are all the things. Yes, chair, iron, wood, plastics, table, steel, wood, plastic, glass. Yes. 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 So activity number 2. Activity number 2 says table 2.2 lists some common materials. You can also add more materials in column number 1 that are known to you. Now try and think of everyday objects you know that are made mainly of these materials and list them in the column 2. So this is the column 2. So materials are made from these materials. So wood, paper, leather. And also leather are made of shoes. Shoes are made from leathers. Jackets, plastics, water are made. Boxes, lunch boxes. Yes. Now cotton, they are made from cotton. Cotton is made. There's a roll of cotton. We will write a roll of cotton. Roll of cotton. Yes, that comes in the market for cotton. Or can write clothes, clothes. Yes. So here, what do we find from these tables? So we have to read this Buju. Buju wants to know whether we found some materials that were made using that were used for making more than one type of objects. So like we can say wood. Take an example of wood. Chair is made, table is made, plough, bullock cart, papers. Yes, these are all the examples. Buju was wondering, so his wondering was right. Yes, his wondering was right. Yes, so here we are. What do we find from these tables? Just a minute. Let's change. Yes, here we are. First, we group objects in many different ways. We then found that objects around us are made of different materials. At times, an object is made of a single material. Yes, single material. An object could also be made of many materials, and then again one material could be used for making many different objects. What decides which material should be used for making given objects? So in the paragraph, the author is trying to say that what do we find from these tables? So from these we found that from one object there are many things that are made from one raw material. Like let's say paper. Let's say, yes, from paper, books, notebooks, newspaper, toys, calendars are made. From leather. Just a minute. Shoes, jackets, yes, are made. So yes, so let's go to the next page. Just a minute. Here we are. Let's read. Yes, that we need to know more about different materials. So 2.2, properties of materials. Yes. So have you ever wondered why tumbler is not made of a piece of cloth? Keep in mind that we generally use a tumbler to keep a liquid. Therefore, would it not be silly if we were made to make a tumbler out of cloth? What we need for a tumbler is a glass, plastic, metal, or other such materials that will hold water. Similarly, it would not be wise to use paper-like materials for cooking vessels. Why paper can't be used to cook vessels? It can't be used because the paper are very too thin. Yes, paper are too thin. Yes, so it can't be used because paper are too thin, and when it would be burned, the paper will also be burned. Yes, at very low temperature also. Like when it would be 30, not 30, like let's say 50. Let's say 50. Yes, let's say 50. Let's say 50. Yes, so 50 the paper could burn easily. Paper could burn very easily. Okay, so we see then that we choose a material to make an object depending on the properties and the purpose for which the object is used to. So what are the properties of materials that would be important for their usage? For some properties are discussed here. Yes, appearance. So what are appearance? Appearance is a very important topic. You must highlight it darkly. Materials usually look different from each other. So wood looks very different from iron. Iron is different from copper, aluminum at the same time. That there may be similarities between iron, copper, aluminum that are not there in wood. Yes, there are similarities. You okay? There are similarities. So activity 3. Collect some pieces of different materials: paper, cardboard, wood, copper wire, aluminum sheet, chalk. Do any of these appear shiny? Oh, appear shiny. Separate the shiny material into a group. So what are we doing mainly in this? We have to make a this here. You have to, for example, have to make a table. What to do is you have to make have to write here material. For example, it's a leather. It's dull. Yeah, its leather is dull. It's a diamond. Diamond. It's shiny. Yes, its diamond is shiny. Yes, and yes, you can understand now. Okay. This is too dark. Highlight it here. Yes. Now observe as the teacher cuts material into two pieces and look at what the freshly cut surface. Figure 2.3. So this is a figure of 2.3. So when we move, we will take cutter and then when. So let's take you make a paper roll. That you have to take mainly a paper. To take mainly a paper and just start rolling from here. Yes, you will just start rolling from here until you roll with drawing here. So you have to mainly take a paper like this and start rolling. You have to take a paper and start rolling. And this is a paper. I just color it. Just color it. Just a minute. Paper. Make a paper. 3, 2, 1. You can see here. This is a paper. Nicely drawn paper. So I will just after that I will make a line. Just from here. Just go from here and then just roll from here. Just roll and make a stick. Stick would look some like this. Yes, and now cut with a cutter. Cut like this. So this is perfectly. It would look like this. And think it would look like. It would look like this. Yes, it is cutting. Just from here it's cutting. So that is what it's trying to say. What do you notice? Do the freshly cut surface of some material appear shiny? So it's no. It's no. Include this object also in the group of shiny materials. Do you notice that such a shine or luster other materials? Cut them away as you can. Repeat this in the class with as many materials as possible and make a list of those with and without luster. Instead of cutting, you can rub the surface of material with a sandpaper to see its luster. What is that? Shiny. Shiny. Let's just call shiny. Yes. So this page is completed. Let's move to the next page in 3, 2, 1. Here we are. Yes, so materials that have such a luster usually metals, iron, copper, aluminum and gold are example of metals. Just a minute. Yes. And gold are example of metals. Some metals often lose their shine and appear dull because of the action of air and moisture on them. These therefore metals like iron, when composed when open to oxygen plus air plus water, to air plus water, take a beaker. I will explain your method. Take a beaker. Yes. Put a slate of, or we can say put a piece of iron, half in it with water, right, H2O plus air. Air is automatic. After 1 or 2 days, you can see rust of the brownish all over. Yes, so it's indicator of rust. Okay, the rest is very. You can prevent rust by coloring the iron. Yes, by coloring the iron or mixing some metals like iron plus steel. No, iron plus carbon makes steel. Yes, so it steel also catches junk but less than iron. Okay, so material which can be compressed or scratched easily are called soft. Some other materials which are difficult to compress are called hard. For example, cotton or sponge. While iron is soft, while iron is hard. You can easily sponge can easily squeeze a sponge, so it's soft. And when iron is hard, so in appearance, materials can have different properties like luster. So what is luster? Shining. Shining is luster. Yes. Hardness, be rough or smooth. Can you think of other properties that describe the appearance of material? So let's say you can take luster first for its luster, and there is luster and sonorous. Some metals when hit, for example, I will hit the steel with this steel. You can hear that sound, that is sonorous. And while I hit a pen with a steel, not it would not like when I will hit a steel with it's very sonorous. Yes, it's sonorous. So while I will hit it with a pen, it's not good. Hit this, it's not also not good. So different sounds come from different materials. So this is steel plus when I hit it with plastic, it would sound something like this, and when I hit it with steel, it will sound something like this. So there is a difference, as you can hear also. So I will just like this, you can hear. Yes. So soluble or insoluble. Activity 4. Collect sample of some solid substances which such as sugar, salt, chalk powder, sand and sawdust. Take 5 glasses or beakers. Fill each of them with about 2/3 with water. Add a small amount of spoonful of sugar first. So take a beaker, add sugar to it. Add sugar. So what is sugar formula? C6H12O6. This is formula of sugar. Yes, this is the formula of sugar. Okay, this is the formula of sugar. Yes. So add small amount of spoonful of sugar to the first glass, salt to the second, and similarly add small amount of other substances into other glasses. Stir the contents of each of them with a spoon. Wait for a few minutes. Observe what happens to the substance added to water. So when sugar is added to water, sugar automatically disappears. So it is not gone, it just dissolves. But I will explain you with a very good example. So this is a molecule of hydrogen, and this is a molecule of not this. Just a minute, I'll just make it nice. We'll make like this, and here it goes like this. Where the stick oxygen is attached. Okay. So what the sugar does? The space between, I will just make it good, just a minute. I will just make for example, this is a hydrogen molecule, not sorry atoms. The atom and this here is an oxygen. So when they combine, so I should tell you that oxygen have atomic number, not velocity of, so it has 8 atomic valency. So like this is a electron, this is electron, sorry, this is a proton, and around this are electrons. So in first electron, in the first stage of electron roaming, there are only two electrons shown. So it have 8, so it have, so 6 is gone. And in second, 8 roams. So in second, the roaming of this is 8. So oxygen, so let me just draw it very nicely here. Let me just zoom. So this is a, what is, let me just write it over here, make it big, just write it over here with a black. This is what, this is proton. This is protons, just subatoms. So there are 3 subatoms: electron, protons, and neutrons. So for protons with positive charge, electrons with negative charge, and neutron with no charge. Neutrons no charge. Yes. So what does electron do? That electron just move. Let me just change my pen color. Just change my pen color to dark. Like this. So this is a line. There are 2 layers. So in oxygen there are there are 8. So 2 comes in the first stage. So in first stage only 2 comes. Okay, only 2 comes. So first stage is completed of oxygen. So this is of oxygen. This is of oxygen atom. This is a subatom. This is a subatom. This is a subatom. And in protons plus neutrons. Plus proton plus neutrons are present inside that. This is called nucleus. Okay, so there are 2 atoms in the first stage. Okay, so in second stage 8 atoms come. So 8 minus 2 is equal to 6. So only 6 atoms, 6 electrons are remaining, because 2 electrons are on here. Okay, so what in water H2 do is that 6 are put it here. Yes, 6 is put it here. So hydrogen has valency of 1. Okay, so they do nothing, they just combine. Oxygen can combine with 2 hydrogen because to share. So what does do is, so let me just change my this. So what it do is, it just, I will just say, this is a hydrogen atom, and here is hydrogen. This is a proton. So it is also have to hydrogen. So it also can't, because it also can't complete its first stage, because only 1 is there. Because only 1. So it has to share with this. So what it does is, it forms like zigzags. So first electrons are born from here both, and then they share the electrons to complete the fulfill. So what is this? So this is what the combination of 2 atoms comes place. So if there are 8, and if there are 8, so oxygen is independent. So this is, oxygen is dependent on these both. Yes, so oxygen is dependent on this both. Yes. So and hydrogen also dependent on oxygen. So that if oxygen have, for example, let's say oxygen have let's say 11. So first stage also completed, second stage also completed, third stage would be there. So there would be a third. Say this. So this. So there would be a third stage, in which there are about let me just remember, there are about 16. So in this 16 it comes. So there are 11. For example, let's say the atomic number valency is 11. So yes. So first is also completed with 2 subatoms with 2 electrons. In second, it is also completed. So 2 plus 8, 10. So 1 is left. So 1 comes to the third stage. So in this case, also hydrogen would be electrons. We can say hydrogen cube combined. So this is what combination is done. So you will study in higher classes these things. Yes. Okay. Understood? Oh, sound like this. Okay. So this is what I want to tell you. So combination of it. So I was telling that sugar molecules, and this whole is a water molecule. Yes, this whole is a water molecule. First erase, it draw, and here is a sugar molecule with a name of starch. We can say starch, carbohydrate, sugar. Yes, so the chemical formula is C6H12O6. So C6H12O6 or sugar or glucose combines with this. Just fitted its molecules inside this like this. It just fits it molecule like this. Yes, so it just fits inside this. So that is why sugar disappears, because it just goes in, because there is space in between this. So that is why they just go and fit. Okay. Yes, as shown here. So that is why sugar disappears. And to take out sugar, do nothing. Take a beaker with the sugar and plus water. Just heat it. Just heat it. Just draw it with duality. Just heat it. Just heat it. So what would happen? That all the water would evaporate. All the water would evaporate. All the water would be evaporated, and the thing that would remain is the sugar. Only remaining is the sugar. So you can take sugar, or this is the same condition in salt also. Yes, salt. Yes. So this space in water, salt disappears completely in water. This also completely disappears. So I'll just put comma with me, or also. For so let's say completely, so I will put for completely I will put C, and not completely disappears, not completely, so I will put just N. So sugar, it would completely disappear. Sand, no, I will put N. Chalk powder, yes. Sawdust, yes. So yes, only sand is the odd one. So you will notice that some substances have completely disappeared or dissolved in water. We say that these substances are soluble in water. Other substances do not mix with the water and do not disappear even after we sit for a long time. Because after a long time, because see, I will tell you a thing that it is a physical chemical. So I don't think it would come in your viewers. So in your stage of 2023 class. So what is this? That take a beaker, put it with the water after H2O, add salt. First 1 teaspoon. It would not. Just add till you see a little layer, a thin layer below. So what, this is a layer of what? Salt. So this says that the H2 is, the water is full. It can't take more salt. Yes, it can't take more salt, because water says that it can't take more salts, and the salt settles. Yes, so in order to take it more salt, in order to take more salt, you have to stir. You have to either stir for a long time or heat it. So when you would not heat or not stir, this solution is called what? This solution is called saturated solution. Saturated solution. And when you add it more, so when you say that you will take it more salt, you have to say that water, you have to take more salt into it. So what would you do? That let's just put it on heat. Put it on heat. So it would take more salt. After a thin layer would also dissolve, plus 2 or 3 spoons would be added more. It will also dissolve. So this solution is called super saturated super saturated solution. Yes. So this is called super saturated solution. So this have fill, select the next page in 3, 2, 1. Here we are in 15 page number. So long time. These substances are insoluble in water. So water plays an important role in the function of body because it can dissolve a large number of substances. Liquids are dissolved in water, so liquids can dissolve. So when you add lemon juice, it also dissolves. But when you add oil, oil has less density than water, so then it floats. Yes. So activity number 5. Collect a sample of vinegar, lemon juice, mustard oil or coconut oil, kerosene or any other liquid. Take a glass tumbler, fill it up with a half liter of water, add a few spoons of one liquid to this and stir it well. Let it stand for 5 minutes. Observe whether liquid mixes with water. Repeat the same with other liquids. As many different liquids are available to you, write an observation. So vinegar can mix, so mix as well. Lemon juice also. Mustard oil, it's no, and it's no. So vinegar and lemon juice mix as well with water, mustard oil, coconut oil, and kerosene doesn't mix with them. So we notice that some liquids completely mix with water, some others do not mix with water and fall through and what is it doing? And oh, form a separate layer which kept inside. So coconut oil, mustard oil just float above the water, while kerosene just sinks, or yes, it sinks. Kerosene just sinks below the water. Guru suggests that we also check if the liquid that we use in this as well. So Paris is to know gas is also dissolved in water. So yes, gas is also dissolved in water. Okay, so I will tell you a fact. So you would hear a pH level in your higher grades. A pH level. It starts from 0 and ends to 14. So pure water pH is 7.0. So below 7.0 there is an acidic medium, and above 7.2 it's a basic medium. So what it says that when carbon dioxide is added to pure water, it dissolves and making thus the water acidic to 5.7. It's a weak acid and changes the taste also. This is what, so that is why I rated yes. Paheli is correct. Some gases are also soluble in water, whereas others are not. Water usually has small quantities of some gases dissolved in it. For example, oxygen gas dissolved in water is very important for the survival of animals and plants that live in water. So this paragraph says that, for example, you are wondering, so how fish breathes in the water? You must say that, for example, this is a tub and you just put a fish in it. You just put a fish in this. It has gill. It has here gills. So that is from where? So when oxygen, all the air mixes with water, not all components of air mix with oxygen also mixes with water. So what the fishes do that? It just inhales the water O2 with their gills. When we will jump into this, we can't breathe because we have lungs instead of gills. So that is why paragraph says that. So oxygen may float or sink in water. While doing activity number 4, you might have noticed that the insoluble solid separated out. I separate out what is written from separated from water. You may have also noticed this with some liquids in activity number 5. Some of these materials that did not mix with the water floated to the surface of water. Others may have sunk to the bottom of the tumbler, right? Yes, so we will write yes here. We notice that many examples of objects that float in the water or sink 2.6 dried leaf fall there is a pond, else to let it thrown in the pond float. So still simple knowledge that just draw here this. So water has a density of 1 at above 4 degrees Celsius. Okay, water has a density of 1 at above 4 degrees Celsius. Yes, density of 1. When a leaf is thrown, leaf is having a density of less than water. It would have like 0.5 or 0.7. And when a stone is thrown into it, it just sinks. So this will float because it has 0.5 density. So this would be stone would sink because it has density more than water. So when for example when the water comes below 4, anomalous expansion happens. So I will tell you a experiment that take a refrigerator. Yes, make it refrigerator to go below 4 degrees Celsius and keep a water. For here, this is a stand where water is kept. Keep a bottle over here, fill with water, fill it with water. So don't make a glass. Don't fill the water in a glass because it will break when it comes below the 4 degrees Celsius. Keep in the plastic. Okay. So what would it would do that below temperature 4 degrees Celsius? What would happen? That anomalous expansion would happen. So in anomalous expansion, water expands. Water just expands. So you have heard that in water when it cools it contracts. So why I'm saying it expands? It expands on heating. So I'm saying that opposite of that. So I am saying that water expands below 4 degrees Celsius. So why I'm saying that? Because anomalous expansion happens because hydrogen atom repels hydrogen atom. Oxygen also repels. So that is what happens in expansion also. So this is what. So you will see that half will plus water with half and mark with it. After 1 hour, temperature when it would be about -5 degrees Celsius or 0, you will see that it would be above 5 degrees Celsius. It would be above the half. Which is what is anomalous expansion of water. So density would what happen? It would decrease. For example, per 2 degrees Celsius, it would decrease. No. It would decrease the temperature. When temperature is decreased below 4 degrees Celsius, the density will also decrease. Below 4 degrees Celsius. Okay. Okay, so this is completed page number. So let's move to the next page. Yes, so drops. So we have come to page number 16. 16, no, it's 16. Yes. It says that drops of honey that you let fall into glass of water. What happens to all of these? To all of these. Bujo would like to give him 5 examples of objects that would float and those that sink in water. Bob about testing these same materials to see if they float or sink into other liquid like oil. Okay. So this is nothing. So let's start transparency. So what is transparency? So transparency is the level of how the object is transparent. So this object you just hold it. This is opaque. This is translucent, and this is transparent. This is translucent. This is transparent because you can see his face. His face could be seen, but it's blur. Here his face could not be seen. Okay. So let's see. You might have played the game of hide and seek. Think of some places where you would like to hide so that not seen by others. So why did you choose? So that you've tried to to hide behind a glass window, especially not as your friend can see you and spot you. Can you see all the materials? Those substances are materials through which things can see are called transparent. Clearly, when things are seen clearly through an object, that object is called transparent. Yes, so glass, water, air, and some plastics are examples of transparent materials. Okay. Shopkeepers usually prefer to keep biscuits, sweets, and other eatables in transparent containers. So they keep in transparent containers so you can see and just buy them. So glass or plastic so that buyers can easily see these items. Here you can see they keep kept in this. This is a glass, so plastics. Yes. On the other hand, there are some materials through which you are not able to see. These materials are called opaque. You cannot tell what is kept in a closed wooden box, a cardboard, carton, or metal container. Wood, cardboard, and metals are examples of opaque. So there is also one of kind of material that is called translucent. It is not either too opaque nor its medium. You can see the images but it's blurred. It's blurred. Like here. You can see Bujo's face but it's blurred. You can't see his eyes clearly. Yes. Do we find that we can group all materials and objects without any confusion as either opaque or transparent? So yes, we can group. So you must be wondering, there is mirror. Mirror is not transparent. Mirror is opaque. So take a mirror that's in Hindi, it's called shisha. So when you put light, it's opaque. So it would not reflect. It just reflects. It's a special kind of opaque object. Okay. So actively take a sheet of paper and look through it towards the lighted bulb. Take a note of your observation. Put 2 to 3 just a minute. Let me add next page. Add next page. Here we are. So when it goes, come on. Come on. Just a minute. Here we are. So take a sheet of paper and look through it towards a lighted bulb. Make a note of your observation. Now put 2 to 3 drops of some of the oil and spread it on the sheet of paper. Look again towards the lighted bulb through the portion of the paper. So when you put, let's say a bulb, this is a bulb. This is a bulb. Yes, this is a bulb. It would glow brilliantly. And when you will put a paper in front of you, you will see that its paper would get what we say. So do nothing. Dim your lights. Or just close all your lights. And just take a bulb and just glow it and just make paper in front of it. You would see that paper beside it would glow because paper is translucent. Yes. So when you take a paper and put some oil, and we can see behind, you can make a tracing paper also. Okay. So paper on which the oil has been separate. So let me just take my paper, just a minute. Let me just take up one paper. So here I have taken a paper, this little paper. Turn on the lights, see this, you can see a paper. So when I put it on here, you can see, I will just take my tab over here. You can see little. I can see it is written. And just make it black, very black. Just a minute. And just take a very black. Just make it very black and just over this. I will just make it bold. Okay. here we are. So I will just make it here. You can see the result is over here. You can see it's. You can see here. Here you can see. Let me just turn on the lights. Here you can see. You can see the light patch of the black. That is what I'm trying to tell you. If you put oil on this, it would be more clear. You can see anything out of this. That will make a tracing paper. Just dim my lights. It's very dark. Yes. So where will be? Oh. So we were over there. We were here. Yes, we were here. Of some oil and spread it on the sheet of paper. Look again towards the lighted bulb through the portion of the paper on which the oil has spread. Do you find that bulb is more clearly visible than before? But what you see clearly through the oil paper is everything else on the other. So that is what I'm telling you. This oil paper move it towards the bulb and you can see. Okay. Perhaps not. Material through which object can be seen but not clearly are known as translucent. Yes. Remember the oily patch of paper when tasted to food items by traces of fats. So I told you in previous chapter when oil contains fats, that is making the paper oily. Oiler you can see. That is a test of fats. I told you in previous chapter. That word's translucent too. Can you think of some more examples of translucent materials? Like butter paper. Butter paper you can say. You can take butter paper. Tissue paper. Tissue paper also. A thin tissue paper. Too thin tissue paper. Yes. We can therefore group materials as opaque, transparent, translucent. Paheli suggested covering the glass of a torch with her palm at the dark place, switch on the torch and observe the other side of it. She wants to know. Palm of your hand is opaque, transparent, translucent. So it's very tricky question. Yes, so let's find out. We learned that materials differ in their appearance. We learn that materials differ in their appearance. So just take this. Appearance of the way they mix in the water or other liquids. They may flow. Can you see? This. They may float or sink in a water or may be transparent. Opaque or translucent materials can be grouped on the basis of similarities or differences in their properties. Yes, they can be grouped. Why do we need to group materials? That must be a question. We need to group materials because to ease us to find it, because for example take English. There is nouns. Nouns are different. Like 5 nouns are there: material, common, proper, collective, and whatever it is. Yes. Though we make groups because to make us easy. Just to make the focus. Yes, you can see. Yes. In everyday life, we often group materials for our convenience. At home, we usually store things in such a manner that similar objects are placed together. Such an arrangement that helps us to locate them easily. Similarly, a grocer usually keeps all type of biscuits at one corner of his shop, or something on another corner. Yes, on another corner. While other green person are stored at some other places. Okay, so there is another reason why we find such grouping useful. Dividing materials into groups makes it convenient to study their properties and also observe any patterns in these properties. And you will learn about this in higher classes, as I told you. So we can say that hand is opaque. So why do we see? This is a very tricky question. So So I will answer that we can see because a hand, because but the torch is white but we see it's red. We see the hand is red because of RBC. Because when we take any, this is my hand, it's opaque, you can see. Yes, it's opaque, as you can see. Okay, it's an opaque. So when I make it over here, so it's opaque. Hand is opaque. The clear answer is hand is opaque. So why would we see? Because light would enter us, because it's too close for hand and RBCs are there, so that is why we can see. So this is as you can when I'm in 7th class and I will tell you. Okay, so these keywords, and let's do the exercises in 3, 2, 1. So here we are to our summary. So let's read summary. Object around us are made from that variety of materials. Let us take my Murasik. A given materials could be made of large, not too dark. Take this light. Also possible that our object can be made of single material or many different types of materials. Different types of materials have different properties. Some materials are shiny in appearance while others are not. Some are rough, smooth. Similarly, some materials are hard, whereas some others are soft. Some materials are soluble in water, whereas some others are insoluble. Some materials such as glass are transparent, and some others such as wood and metals are opaque. Some materials are translucent. Materials are grouped together on the basis of similarities and differences in the properties. Things are grouped together for convenience and study their properties. Okay? Got that? Okay, got that. So, exercise. Name 5 objects that can be made from wood. 5 objects are. 5 objects are. Let's say it's. I will zoom. I will write paper. Write the copy. Paper. Chair, table, paper, chair, table. Just write in a copy because I will erase. Paper, chair, table, cardboard, or let's say cardboards. That what we say, doors. These doors. Yes, so you can take a screenshot of this. Taken. Yes. Okay, taken. Yes. Select those objects from the following which shine. So glasses. Don't say bowl signs, glass bowl is the sign. Plastic toys doesn't. Plastic doesn't. Steel spoon, yes. Only steel spoon shines. Okay. Match the object given below in the materials from which they could be made. Remember, an object could be made from one or more materials, and the given material could be made from many objects. So glass can be made from materials objects. So wood book. So wood materials. Paper, from paper. Book I will make of paper. Yes, so tumbler, glass tumblers, plastic tumbler. Yes, chair, from wood chair. Chair can be made of plastics. Toys can be made of plastics. Yes, Yes, toys can be made from plastics. Okay. And shoes can be made from leather. Shoes can be made from leather. Oh, shoes can be made from leathers. And shoes can be made from plastics. Okay. So write it on front of this in very clear. So glass, I just number here it's 1, 2, 3, 4, 5. So from glass 2 can be made. From glass only 2 can be made because glass tumbler. Yes, plastic also 2 can be made. Toys can be also made from plastics. Chair can also be made. Yes, and shoes from leather can also be made. Leather shoes are made. Okay, and the book, toy, paper from paper, book can be made. Paper, book can be made. Okay, paper, book can be made. From wood, book, yeah, book can be made from wood. And chair can be made. Plus, from glass, tumbler can be made. Yes, so that is what. So, oh, what happened? Yes, so I will start it again. Yes, I will just match it. Wood, paper, yes, tumbler, glass, match it. Chair from wood, plastics, okay. Toys, not leather, from leather. Toys can be made from plastics, okay. Plastics also made, and from shoes, paper, leather is made. From shoes, leather, okay. So I have just numbered it. This is numbered. Okay, shape of the statement is zero, true and false. Stone is transparent while glass is opaque, so this is false. No, notebook is luster while it is not. So luster means shiny. So notebook is not shiny, so it's false. Either eraser is not shiny, either notebook is not shiny. Both are not shiny. Yes. Chalk dissolved in water, it's true. A piece of wood floats in water, it's true. Sugar is not dissolved in water, it's false. It's all mixed in water, it's false. Okay. Sand settles down in water, it's true. It's true. Vinegar dissolves in water, it's true. Okay. Then below the name of some objects and materials: water, basketball, orange, sugar, globe, apple, and earthen pitcher. Do the mass round and other shapes. So water is not no shape. So water can come in this. Yes, this. Basketball in this, ball, orange in this. So orange will come in both. Water can come in this also in both. Sugar can come in this and also in this. Globe can come in only this, and apple can come only in A. So I've write in above only, above. C. Water can come in A and B, other side AB. This also come in, this will come in not B, it's A. It would be A, round and other shape. Orange also in AB, AB. This is also AB. Globe it's A. Apple it is. Apple it's A, B. Apple it's AB, and earthen pitcher. What is this? Earthen pitcher. I'm forgetting the name. So I think it's not eating thing. It would be A. It would be A. Okay, so you can take a screenshot. Earthen pitcher. Yes. So 6th, list all items known List all items known to you that float on water. Check and see if they float on oil or kerosene. So this is your own activity, so you do as homework, because as my convenience is more. So for example, I take leaf, they just float on water, and I just take stone, it settles, it sinks on water. So in oil it floats, and kerosene it's also think it's float. Kerosene is oil, so it's float. It would float. Yeah, it would float. Okay. So an oil it would float, and kerosene it would also float. So this is your homework. Yes, and the 7 questions had the odd one out from the following: chair, bed, table, cupboard. So baby it's human. It's human, so it's living or a non-living. Rose, jasmine, board, marigold, lotus. So all are flowers instead of board, not board. Aluminium, iron, copper, silver. All are metals, but sand non-metals. Sand is non-metals. Okay. Sugar, salt, sand, copper, sulfate. So sugar, salt, sand, copper, sulfate. So just a minute, let me think. So yes, it's all dissolvable in water. So copper sulfate and sugar can dissolve in water, but sand cannot. So the answer over here is this, sand. So this activity you have to do at your home and on HW. Complete your both HW, and today we have completed our chapter in 1 hour. So bye bye. Have a nice day. And please like and subscribe my channel and post your doubts in comments. So thank you and have a nice day.